Hi, welcome to the video presentation for the project of subject SER502 Emerging Languages and Programming Paradigms. I am Nikhil Tibrewal. So we are building a language which is called JBB. It is a high level and a user-friendly imperative language. It is designed for users who want to learn the basics of a programming language. So let's start with how its grammar works. So the grammar's first line is finale goes to main, then curly braces, then variable declaration and statement sequence. Now we can see main is a keyword, and because finale is the root of our parse tree, this keyword is a mandatory in the language. And variable declaration is not mandatory. It can be there, it cannot be there, that's fine with the compiler. And statement sequence has to be there. Now let's go to each one of them. Variable declaration looks something like this: type declaration followed by identifier, then followed by sub-variable declaration, which is optional, which can be 0 or multiple number of times. So sub-variable declaration is comma followed by identifier, which means if we want to declare just one variable, we can say something like num x, then x is declared. If we want to use the sub-variable declaration, we want to declare two variables. For example, if we give num x comma y, so it will accept that. Next is type declaration. Type declaration has to start with either a num or a bool. These two other types which we are supporting. Then statement sequence has to have at least one sequence followed by a semicolon and another statements. Now this part is optional. Optional means it can be there zero number of times or it can be there any number of times. Now a statement can be of four types, either if statement or while statement or assignment or print statement. We'll talk about all of these in a second. So assignment is a keyword assign, then the identifier to which we are assigning the value, then colon followed by equal to, and then an expression. Expression can be anything, which we'll discuss in a while. Then print statement. Print statement is using the keyword echo followed by an expression. If statement has the keyword if, then boolean relation, and then the keyword then statement sequence, then else statement. Now else statement is optional. If we don't have else statement, that's not a problem for this language. Let's talk about the while statement. While statement goes something like this: while boolean relation do statement sequence, which can have any number of statements, followed by OD. Now what is a boolean relation? Boolean relation is expression, then a decision, then an expression. Decisions are these: double equal to, not equal to, greater than, less than, and expressions we are going to discuss now. So expression can be term followed by any number of sub expressions. Sub expressions are plus or minus sign followed by term. Then a term can be factor followed by any number of subterms. This has been done to make sure that we don't have complexity or ambiguity in the code. So next is factor, which can have expression inside parentheses, then identifier, then number. Integer can be one digit followed by any number of digits. Number can be integer, then optional dot followed by integer or any numbers of integers. This is the support for float integers. Then identifier can be character followed by any number of characters or digits. So whenever we define an identifier, it has to start with a character. Character can be A through Z, all small and uppercase. Digits can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This grammar will be the input for the lexer, which will generate tokens, which in turn will generate parse trees.
Hi, I'm Akash Chok, and I'll be walking you through the lexers and parsers. Now we have the grammar file, and we need to generate the parse tree. So this is done using lexers and parsers. So before diving into the code, I would like to explain how the lexers and the parsers work. Lexer is nothing but a software that scans your input character stream and generates tokens. Now these tokens can be generated using any delimiters. These delimiters can be a new line or a space. So Antler by default uses space, and we have tokens. Once we have the tokens, we feed these tokens into a parser. The parser can employ various techniques such as the top-down approach or the bottom-up approach. Antler uses the LL star approach, which is the top-down approach. Now once we have the Antler, we execute these commands to get a list of generated files. These are the generated files wherein we have the listener class, the lexer class, and the parser class. Now I'll dive into our code and show you how the execution starts. So this is the starting point of our code. We provide in the path of the high level language, and we provide the path of the intermediate code. Once these are provided, we start off with the lexers. This is the lexer code and the parser code, which ultimately generates a parse tree. Herein we take the input file and it starts generating the lexers. Whatever lexers we have, we pass it into the parser, and the parser parses it using the LL approach and creates a parse tree. Once the parse tree is generated, we need to walk through it. So we implement the walker, and as we walk through it, there are various functions which are employed in the base listener class, which we'll be explaining later, which are important for us to create our intermediate code.
Hi, my name is Suchir Namdar from Team 11. I'm going to discuss the application structure of our project and how we have implemented the listener class. So to begin with, our application is divided into 4 different modules: compiler, master, parser, and runtime. Parser is where we have our grammar, and compiler is where we are using the instances of the parser classes which was generated through the grammar to implement our listener classes. So if you see here, we have different enter and exit functions, each of which are executed as and when the walker enters into a statement and leaves the statement. So for example, when the walker enters the finale, that is the main function in our code, it is going to perform the following operations. To begin with, it will write the str at the beginning of the code, and then at the end, when it is the time to leave the total function, is when it is going to write end onto the intermediate code. This is the method through which we have implemented different enter and exit functionalities, each of which are customized in order to generate the intermediate language which is best executed by our runtime environment. Just like I had explained, this is how we have the start at the beginning of the code, following by the declarations, then the assignments, and the other operations that form the substatement in our grammar.
Hello, my name is Abhimanyu Dogra, and I'm going to talk about the runtime module. The runtime is a Java application which reads the intermediate.jbbo code file and executes each instruction inside it. It is responsible for giving meaning to the language. It creates and maintains a symbol table which stores the value as well as the data type for user-defined and temporary variables. It is responsible for type checking. For example, in case of arithmetic instruction like add, it will ensure that both the operands are of same numerical data type. Now let's look into the code for the runtime environment. Once the intermediate code file has been generated by the compiler, master method then invokes the execute method of the runtime environment. The execute method then reads the file and loads it into an array of strings. Then it invokes the tokenize method, which splits each instruction based on the space character delimiter. Then it calls declarations, which goes through user variable definitions and creates appropriate symbol table entries for them. And finally, it invokes statement sequence method, which handles the body of the intermediate code. Now let's look into the code for statement sequence. Statement sequence checks the OP code of the instruction, and based upon what kind of instruction it is, it will call the corresponding method. For example, if it encounters add, it will call arithmetic operation method. Now let's look into the arithmetic operations source code. The arithmetic operation method then checks the left operand if it's already available in the symbol table or if it's a number. It repeats the same process for the right operand, and then based upon the type of OP code, it computes the final value and stores it into the symbol table. Finally, we have the print statement, which prints the value to the standard output. Here's an example that was written in the JVB language. Here's the intermediate code that was generated by the compiler. And here is the output that was generated by the runtime module.
Let's take a quick look at the basic possible examples. Just see, this is just a code main which is echoing just one. This is syntactically correct as per our grammar. So when we create an output file for this, it gets compiled and output file is created, and when we run the output file, it gives the output as expected. Now let's make some changes to enter some errors into it. For example, if we enter semicolon over here, so this is syntactically not correct. So when we compile this, it will say that we have a mismatched input and it will not, compilation will not go successfully. Similarly, if we add another line, say echo to, and here this is again syntactically not correct because this semicolon is present here. It should again fail saying the same thing. Now if we remove this semicolon, it works well. We can compile it, we can run it, and the output is as expected. Now let's see an example which is a little bit complicated, which has if condition and complicated expressions. So here we are declaring numbers p, q as boolean b. We are providing values to p as, and we are providing the value for b to be true. Now if condition, if b not equal to true, which is incorrect, so it will enter the else statement. Here we can write a complicated expression, suppose say 22 plus 23, which is 45. Now we can subtract 5 from 45 and then multiply it with, say it's 40 into 10 should be 400, and say if we subtract some value of 100, it should assign value for s to be 300. Let's see how it works out. So it provides the value to be 300. Now
I'll be walking you through the factorial program, which demonstrates the use of the while construct and how our high-level program handles it. So this is a factorial program. These are the declarations, and we assign a value of 6 to x. This is the while construct, which will run for at least 6 times, and each time it runs, it will multiply for the first iteration 6 into 1 and store the value into fact, and for the next iteration it will do 6 into 5, and consequently until x is greater than 0. While x is greater than 0 and while x is equal to 0, it will come out of the loop and echo the value of the fact variable. So we have a value of 720 for a value of x is equal to 6. Similarly, there's one more example, the Fibonacci series, and I'll show you the output for a value of x is equal to 6. Let's run it through the console, and here you get the output as 13, which is correct.
Okay, now let's take a look at another more complicated example in which we have nested if and while loops. So if you look at the main structure, which is pretty much the same for all of our programs, that is, we start with the declaration of the variables, followed by the assignment of the variables, and then we have the if loop, the else part of it, the while loop inside the if loop, else part, and then another while loop which is inside the previous while loop. So let me just execute this program. Okay, now that we have not received any error messages, it means that our program has correctly executed and created an intermediate file. In order to run this file, we will be using the -r option with the nested.jbbo, which is the output of our previous command, that is the intermediate file. Okay, now that we have run this command, we can see that the output is as it was expected. So let's just traverse through it real quick. So here we have an if loop which says x plus y is less than or equal to 3 into 5, which is 15, and x plus y through our variable assignment is 33, and which makes this condition false. So the Boolean expression is executing perfectly, and because of which we are not seeing the value of x as 1. Moving on into the else part, where we assign x as the value 2. So assignment within the else part, or assignment within the substatement, is supported by our language. Then we have the echo x, which means it is going to print the value 2, first output over here. All right. So moving on, we have while y is greater than 2. So we had initially initiated y at 32, and we are going to decrement y by 5 in each of the iteration. In the do part, that is the whiles in body, we have while loop, which is for evaluating the value of t. And we are first seeing if the t is greater than 400, which it is 405, and we have assigned t is equal to t minus 1, so it is going to reduce it 5 times. So we have 404 reduced once, 3, 2, 1, and 400 finally, which is reduced 5 times. Since it is going to print first and then evaluate later on, we have one additional execution over here, which is as per our design. And then we have the while loop, which is executing over and generating the other values, say 22, 17, 12, 7, and 2. And when the value becomes 2, we have the while y greater than 2 statement becoming false, and the whole program terminates as so. So this is an implementation which shows that our language is capable of handling nested conditions and loops. Thank you.